So welcome back students. So today we are going to work with ESP32 S3 and today our work scenario is to work on the cores. If you see anywhere people usually don't talk about the cores. Core it's like a dual core or like the processor of any microcontroller. So right now I will try to demonstrate the things that how the cores are working, and then we will move with our project. And today we will try to work with both the cores, the core 0 and the core 1, and let's see that what will be our result. So let's start. So today let's first see this. So right now we are working with this ESP32S3. It's like a room 1, and you can see the basic architecture of this ESP32 which we are working with. And I will go down, and you can see here like the model, like how the things are working, which GPU is like working with what, and all these things, USB, UART, reset button, boot button. These are the normal things. And you can see also this antenna, so that it communicates with like Wi-Fi or over Bluetooth, and like GPIOs, JTAGs, and ADC touch. Other all things are like available in this powerful microcontroller. So as of now, I was saying about the CPU architecture. So it has like for ESP32, we have the Extensa LX6 dual core 32-bit. The cores are like dual core 0 and core 1. Typically it have the flash from like 4 to 16 MB. So here I want to say like ESP32 is a place, like suppose just imagine for beginners, like two employees are working and they are like handling two different tasks at the same time, and like it increase the efficiency of the work. So as in core 1, I name core 0 and core 1, they both usually run at the same time. And when the tasks are in the parallel, so like they handle the two tasks at the same time. So it doesn't mean like the program run the twice faster, but yeah, it means like microcontroller can do the multiple things at once, better for the multitasking. So please be clear, dual core doesn't mean like it will increase the speed of this microcontroller. It will just like it is going to do the same like two different tasks at the same time. So let's start. So today our agenda is like we will try to work with both the cores, means both the memory, both the brain, core 0 and the core 1, and we will see that how they both are working at the same time. Parallelly they will work. So let's start. So before we move, as you know that we are working with ESP32 IDEA. Our environment will be Windows subsystem for Linux. We will start from scratch so that everyone can understand better. So let's start. So we will open the Ubuntu. Okay, I will do the full screen so everyone can understand. Okay, so you can see that we have all the environment already been downloaded. So we will create the project. So first we will go to the inbuilt directory which we have already, DSA. Here I will start the first we have to create the project. So for this we have to type ids.py create project, and what should be the name? The name will be course. Okay, so it will be better for us, course. Look, the this project or this thing has been already created, so we can work with it. So let's go inside this project. So dsa / course dot. Okay, now in the previous videos, like I already told you, like we have two CMake list. One will be for the root, another one will be in the main. So let's see the root of root one as well as the main one. So here nano CMake lists.txt. Look, it will give you that, like you can understand that yes, the project is successfully created and it can execute successfully. So there are no default case. Similarly, we will go to main cd main, now nano cmakeLists dot txt. Look, so as the name of our project is course, so it's showing course.c. and if you are like working with various projects, so you can include that things and it will be easy for everybody. So right now we are working with only single project, so there is no need to do anything here extra. Now let's go to the coding part. So nano, okay, it's already been created, so we will write. Okay, so let's start. First I will write the code and then I will explain that what it means and what each single line are saying, so we can understand it better. Okay, so let's start with the basic libraries and all the necessary things, and I will write the code. You can if you want, you can also see, and let's start then. So first, we wrote the complete code, and so here, okay. So I think we are done with the coding stuff, and let's explore the code. I will try to explain the code what I have written again, so that it will be better for understanding and everyone can understand better what it means. So I will explain you. I will try to explain better way so that everyone can understand. So I will like increase the size of the screen so that you can see it clearly. Okay, so let's start for the first one. So here, like suppose here this defining LED1 GPIO2 and LED2 GPIO4. And so here it is like I'm defining the GPIO pin for this blinking. So built-in LED, like or like external LED, anything we can add it in this. And then we are going here. You can see void LED task 1 and this. For this, like it means like task to build the LED1 on core 0. So this whole this like while this function and every this loop has been created for the core 0, okay. And then similarly, if you go on void this one, if you say, I will write here so that you can understand better. So this one, and I will write like core 0. This is for core 0, core 0. Here will like core 0. Similarly for here core 1, core 1, okay. So here like you can see the timings also, we can see like delay for 500 for core 0, and then here for LED task 2 PV parameters, and then here you can understand like 1 means turn on the LED, and this is the delay which you are providing. 1 means like turning on, 0 means turning off the task delay, like the timing, the delay, so that you can see the blinkings. And then we will go with the main, okay. Like here I'm here, it's like void app main. So it's showing like I will say like set GPIO as output. You can say set GPIO as output. You can see also here. So here this one, and the main thing is like this one. You can see xTaskCreatePinnedToCore LED task 1. This task 1 LED1 task. For this one, like here I think yes, I think yes, yeah. So here it's like create the we are creating the first task for the core 0. That's why it means 0. This is for core 1. That's why it's 1, core 1, core 0. And maybe you will ask about like what is this 2048? So here 2048, I want to say like it's 8 KB of the stack memory for the task, okay. So in the course, like if I will say like they will run at the same time. So I am providing the code that like it will have this stack memory for the task. This 2048 is like 8 KB, okay. And then what other things we need to discuss here, I think yes, before we are moving with these things like 2048 and everything, I think you guys understand the coding which I wrote. It's a very simple code. It's like you can understand easily. Like here we have defined the LED for the GPIO pin number 2, number 4, and then we have gone with the while loop. While loop has given the instruction that how the our programming will work to run the code on the microcontroller. Similarly for this is for the core 0, core 1. Again I will explain you what does it mean like core 0 and core 1. So look, in simple word, again I will say like suppose if you are working in any company, or suppose you are working somewhere and only one people is working. It means only one people is working, so you are like handling any task, one tasks like single at a time. But if you have a two employee in that company, you are like handling two different tasks at the same time. So it like increase the efficiency. You can do multitasking. It's like multitasking. So ESP32 come with dual core, means like you can say like it can perform multitask, like two tasks same at a time. Again I will want to let you know, it's just performing two tasks at the same time. It doesn't matter like it will if you are performing any single task, it will go with the double of this speed. It's nothing like that. It will go with like just simple as that. Like if you are working with two different tasks, it can handle efficiently two different tasks. If you talk with other microcontrollers like Arduinos and all these things, some of them or like most of them come with the zero like only one core. It means they can like handle the task, one task at a single time. They don't have that multitasking. But for our case, we are working with this ESP32. So we have or we are blessed with two different cores, core 0, core 1. And again, I think I will open this here. One more thing, here you can see, I will zoom it a little bit. Look, these GPIOs. Again, I will tell you what is GPIO. GPIO means general purpose input output. So you can like connect any external thing with with using these pins, GPIOs, and you can like perform your any experiment or any task as per the need. Now RTC, you can see RTC. There is various, you can say the RTC. So as I studied, RTC can be like, we can define like it's like a fast memory. It's provide like I think up to 8 KB, and like it's like retained during the deep sleep. And some similarly like RTC have fast memory, RTC slow memory. It like work with like 8 KB and retain for this ultra low power sleep. So yeah, these things. So we are done with the coding also. So now we have to simulate the code. So let's see whether our code is working or not. So here, let's now work with this hardware part. So as I told you, like let's go with the diagram of our ESP32. So we are working with which GPIO? GPIO 2 and GPIO 4. So GPIO 2 will demonstrate the working of core 0. Here you will write core 0. Let's write so that you can understand the things better. Core, let's write core 1. Okay, so here in this diagram you can see number 2. Where is number 2? Here is number 2. Yes, I think yeah, this is number 2 and this is number 4, GPIO. So here we will connect our LEDs, and we will simulate the thing. So let's check whether our written code is correct or not. So here we wrote this code. We will find anything wrong. Let me check. I think everything is fine. Maybe I will see one more time. Okay. Okay, let's run it. If there will be any issue, then in that case we can see it and we can correct it. So Control X, Control Y, enter. We are not supposed, like many of the students are doing this, simulating it wrong, and they are like running with various issue. I will show you. Look here, it's showing main. We are still in the main, and if we will run the code here, it will run with the error like CMake error and different type of error. So we need to suppose, sorry, so we have to perform, or we need to simulate it at a right place so that it can be simulate, or it can compile and we can observe the result. So we have to go outside of this cd dsa and then codes. Okay, and then we need to, like, if we have written the codes idf.py, first we have to do some settings. So let's change the setting, then only it will work. So menu config config. Here we will go first in the component configure, and we will search for ESP system settings. This is system setting. This is 160. We have to enable for 240. It's the maximum capability, 240. So that's why we have done it 240. Okay, and then we will go to the serial flash configure. We will increase the size of this flash up to 4K, this 4. Then we will go outside. Still we are not done with it. So we need to tell to the environment that we are working with which particular ESP. So here in this case we are saying, I will show you, we are working with like ESP32 S3. So we have to write here idf.py set dash target. Okay, ESP32 S3. Okay, now everything is like well and fine. So let's connect our ESP32. So this is our ESP32. I already connected with the GPIOs I told you, number 2 and number 4. So it will show you the working. So let's start. Okay, now this is not necessary for everybody, but those who are using Windows computer and they are using the Windows subsystem for Linux, especially WSL2, they have to do this task, or they need to configure this. So we have to go for the PowerShell. We have to run as administrator here, and then we will write USB, IPD, and list. We have to see that what the devices are connected with our computer. Look, here it shows the bus ID 2-1, USB serial device are at COM7. So we need to attach this. So here we will write USB, IPD, and attach WSL, bus ID. And what is the bus ID? It's 2-1, 2-1. So now we will execute our code and we will see that whether our code is working, we have write the code in a proper way or not. So idf.py build. So here we will build, enter. Let's see, let's hope for the best. Yeah, so there was no any error or there was nothing wrong in our code. So it's showing that yes, this has been executed successfully. So you can transfer the things which you have written inside your ESP32 microcontroller. So for this, idf.py flash, flash flash, enter. Okay, let's wait. Now we have to monitor that whether which thing are working with what, which thing are working with what. So idf.py and then monitor. Okay, look, it's showing like there are two different cores, and the both cores are working differently or like simultaneously, but they are not linked with each other. So I will demonstrate on the breadboard. I will connect the LEDs here so that you guys can see it and observe the results. Just 1 minute. Look, so I think I will try to, my cable is not that long, but I will show you, still I will show you. Yeah, look, this, look, there is a difference. They are not blinking at the same time. They are like one is blinking with different timing. So if you say I will like execute something different in the code, so you can understand what's the like how they're like working differently. So we will just like do something changes in the delays. So let's change something. Let's wait. So first we will stop this code. Okay, and then we will go for cd main and then nano cores, cores code dot c. Okay, let's change the timing. Here it's showing 500. Let it be 500 for the core 0, and for core 1 we will go with the 2000, so we can observe the difference. Our only motto is like to observe the difference, nothing else. So 2000, control X, control Y, enter. Okay, and then again we need to boot. So idf dot, not in the main, sorry, cd, then dsa, and then course, the name of our project, course. Okay, here idf dot py build, enter, and again it will compile and we can see or we can observe. Yes, then idf dot py build, oh no, sorry, flash. And we can see the both the cores will work with their own different times. Look, I think I will show you. Now observe the LEDs blinking. They are not same. For the 2000, this one is for 2000. It's delay. So look, it's blinking at a very slow speed. So you can understand like both are working with two different cores, not with the same cores. It means like if you are working with any other projects, like suppose you are connecting any sensor with your ESP32 with core 1, you can say, and core 0 is connected with any Google cloud or any cloud like Amazon AWS, and you are like collecting the data from sensor core 1, and like then after collecting the data you are sending the same data to the cloud like on Amazon AWS. This is also a possible way to do the multitasking. It's not that essential, but like for this case, but like if you're working with this core 1 and core 0, if you know that how to tackle with multitasking on ESP32, you can do it, do this thing. And again, now let's make this experiment more interesting. So I have a buzzer. So I have a buzzer, I got it from my university, and this is LDBZEZ1205. So on core 1 we will remove this LED. Let's remove, and let's put this buzzer here, and wait, look, that LED is blinking at like it's working on their own. It's nothing related with this buzzer. Look, buzzer is working at a different speed, and this LED1 or LED1 is working with different speed. So this was our experiment which we tried, and we try to demonstrate that how the cores are working. I have one PowerPoint also, so I will try to explain so that you can understand and you can implement. So I will stop this first. Let's remove the buzzer. Okay, and maybe I have on downloads. I will. So let's recap, and let's see that whether we have done it nice or not. So what is ESP32? So ESP32 is a powerful microcontroller controlled by expressive, and it includes like Wi-Fi, Bluetooth, and many GPIOs. Has two cores which we study in this class, the core 0 and the core 1. It is great for multitasking and real-time application. And what is the core? Again, I will explain you. It's like a brain in a microcontroller. So ESP32 has two cores, two brains. Like most MCU, which I already told, like Arduino have only one. They can run the task in parallel simultaneously. Core 0 Pro CPU handles like Wi-Fi and Wi-Fi task and other things, and like Core 1 is for like applications. It's like run user application, and you can assign tasks to any core. Why two cores? To run multiple tasks at same time. Example like blink LED on one core and read the sensor on another. Okay, which I gave you the demonstrate like how we can deal it with. It improves the performance and responsiveness. And then FreeRTOS. So FreeRTOS like similarly like FreeRTOS is the real-time operating system we use in ESP32. It allows running multiple tasks independently. Each task can run on core 0 and core 1. And yeah, these things are like, look, like create tasks in code using xTaskCreate. These things are not that necessary. You can also read this, like if you find it like it's like a person with two hands or two brains, one hand blink LED, another reads the button, and which we discuss in our class today. And both hands like work at the same time. That's parallel processing, which I already told you. I also told you like two cores don't double the speed. They improve the multitasking, but they cannot increase or they cannot improve this like speed of the microcontroller. And the ESP decide which core to use, and you can experiment like pinning this. So yeah, this is what we are done with today's experiment, and I hope you like this. And if you have any issue, like you can tell me, and you can like you can mention anything if you have finding any difficulty. If you write the code, if you need this code, this particular code, I will send you. I will give it to you. This code you can use it. And some student will ask like why you are using this ESP32 on WSL2. So I will again tell you, it is a professional way. If you go in an industry, in a big industry, either in Europe or in America or anywhere, most of the people will prefer to use this WSL, not WSL, like they will prefer this Linux environment. They're not going to ask you to work with Arduino, because Arduino is just used for the industry. You can use it with industry prototyping. But if you have to become a pro level expert in this programmings and like microcontrollers and anything, you have to go with their own inbuilt IDFs. Like for me, I am using this ESP IDF. And apart from that, I received some of the comments like when we will start with the AI, how you will deploy this AI into ESP32. You haven't started. So right now, look, we are in a developing, we are just learning the basic things, which is going to work for the university or like for the industry, for the beginner. And once we will be done with it, then we will start with deploying the AI models inside the microcontrollers. And to be honest, right now I also don't have that devices. So I will go to the university, I will bring that sensors, we will collect the data, we will learn the computer vision, we will learn the image recognition, we will learn the predictions, and many more things. Whatever we will have the possibility, and you will comment the things, I will try to implement, and I will try to demonstrate each and everything so that you can learn anything. So right now we are done with it. I will put the code so you can learn the code. And if somebody have the doubt like how to become expert in coding, so look, there is only one way. You have to practice every day. Some of them will ask like AI can also write the code, then why it's necessary to write the code? If you know the code, how to execute the code, then anywhere you will go, you can write it, and you know the things like if you can apply your own logics, because ESPs or like any microcontroller have their own limited memories. So you have to play with the memory. If you adjust anything like inside the memory, or like you have that capability, you are able to apply the logic, you will be respected everywhere. So you have to done with it. And yes, this is all about for today. And I hope this today's demonstration was not only the LED blinking. LED blinking was just one way to demonstrate that what we have done, what we are doing. But today we have worked with two different codes. So today you have learned how to do the multitasking in any not in any microcontroller, but in ESP32. And in the next session, I think we will go with this I2C, and we will try to connect anything with using the I2C protocol. I2C is a communication protocol. Some people say I2C, some people say I2C. So let's see. So yes, thank you so much.